Section 4.3 is titled Solving Equations by Adding or Subtracting. Quite a few definitions here. Some of these maybe you've heard of, but let's write them down anyway. So an equation is a mathematical sentence that contains an equal sign showing that two expressions are equal. The solution is a value for the variable in that equation that makes the equation true. To solve an equation or solving the equation is the process of finding that solution. And inverse operations are operations that undo each other. This is what we use when we solve equations. You may not know that's what you're doing, but you in fact are using inverse operations. For instance, addition and subtraction are inverse operations, and multiplication and division. Equivalent equations are equations that have the same solution. So let's look at the addition property of equality. If you add the same number to each side of an equation, the two sides will remain equal. So for any numbers a, b, and c, if a equals b, then a plus c will equal b plus c. Notice the addition of c to both sides of the equation keeps it equal. So for the examples, we have 4 equals 4. If we add 9 to both sides, we get 13 equals 13. Still equal. And on the right-hand side, we have an equation y minus 5 equals 10. If we add 5 to both sides, we get y equals 15. And that happens because these 5's cancel out. So let's solve some equations and check our solution. In some of the problems on the worksheet, you will need to check your solution, so make sure you understand how to do that. So we want to solve this equation. We are solving it for x, so we're trying to get x by itself. We need to look at what's happening to x. Right now there's a 7 being subtracted from it. So what is the inverse operation for subtraction? Well, it's addition. So we want to add 7 to both sides. Remember, when solving equations, whatever you do to the left, you need to do to the right to keep it balanced. So those are going to cancel. We're left with x on the left and what is negative 4 plus 7. This is where it's handy to remember how to add integers. Opposite signs, so we subtract the numbers, and the answer takes the sign of the larger number, 7. But now we need to check the solution. To check the solution, we're going to take that 3 and we're going to plug it back in for x. So instead of having x minus 7 equal to negative 4, we're going to substitute in the 3 and have 3 minus 7. We're checking to make sure that it is in fact equal to negative 4. Well, what is 3 minus 7? Well, if we add the opposite, 3 plus a negative 7, those signs on the numbers are opposite, so we subtract the numbers. 7 is negative, it's larger than 3, so we get negative 4 equals negative 4. That is our check. So when it says check your solution, this is the process I'm looking for. However, over here, this is the answer to the equation. Let's look at another one. 20 equals x minus 5. We have 5 being subtracted from x. What's the opposite of subtraction? That's addition. So we need to add 5 to both sides. When we do that, the 5's will cancel on the right, and we're just left with an x. 20 plus 5 is 25. So this is the solution to the equation, but we need to check our solution. So I'm going to rewrite the equation. Now I'm going to substitute in my answer for x. We need to check that the left-hand side, 20, equals the right-hand side. Well, what is 25 minus 5? It's 20. So we know our solution is correct. Here we have an example with decimals, but it works just the same. We have 6.4 being subtracted from y. So the opposite of subtraction is addition, so we need to add 6.4 to both sides. On the left, we end up with y, and on the right, we add 10.7 plus 6.4, and we get 17.1. But now we need to check our solution. I'm going to plug 17.1 in for y. Excuse me. Does that equal 10.7? So we're checking 17.1 minus 6.4. 11 minus 4 is 7. Bring down the decimal. 6 minus 6 is 0. 1 minus 0 is 1. We do get 10.7 equal 10.7. So we know that our solution is correct. So let's look at the flip side of that, the subtraction property of equality. Basically the same as the addition. It says if you subtract the same number from each side of an equation, the two sides remain equal. So for any numbers a, b, and c, if a equals b, then we can subtract c from both sides, and a minus c will equal b minus c. Here in our example, we have 7 equals 7. Subtracting 3 from both sides, we get 4 equals 4, keeping things balanced. Over on the right, we have an equation, n plus 4 equals 9. Subtracting 4 from both sides, and we're left with n equals 5. And again, those 4's will cancel, left with an n, and 9 minus 4 is 5. So let's look at a few more examples. Here we have 10 being added to y, and it's equal to 23. The opposite of the addition of 10 would be subtracting 10. So that's what we want to do to both sides. When we subtract 10 from the right, we're just left with y, and 23 minus 10 on the left is equal to 13. So our solution is y equals 13. And we need to check that solution by plugging the 13 in for the variable. So we have 23 equals 13 plus 10. We're checking that the left side equals the right side. 13 plus 10 is 23. So we get 23 equals 23. Another example, m plus 6.7 equals 3.4. So the opposite or the inverse operation of adding 6.7 is going to be subtracting 6.7. Remember, the whole goal is to get the variable by itself. So then we subtract 6.7 on the right. We're left with an m on the left. And now we need to do 3.4 minus 6.7. Well, if we write this over here, 3.4 minus 6.7, we need to add the opposite. Now we have two numbers whose signs are different. We actually need to subtract those numbers from each other. 6.7 minus 3.4 is 3.3. Notice the 6.7 was negative, so our answer is going to be negative, since 6.7 is larger than 3.4. So we get that m equals negative 3.3. But now we need to check our solution. So we're going to plug a negative 3.3 in for m. I'm rewriting the rest of the equation from the original problem. Hello. Yes. Yes. I did 4 for 9 weeks. And it's working. Yes. Yep. Oh, yeah, I did 4 in 9 weeks. And if they say have any left over, I'm collecting them tomorrow for extra credit. So then they don't share. Yep. Yeah, I can email it to you what it looks like. Okay, yep. Bye. Okay, sorry about that. So again, we're checking our solution. We want to make sure that the left-hand side is equal to the right-hand side. So what is negative 3.3 plus 6.7? Again, we have opposite signs on the numbers, negative and a positive. So we need to subtract the numbers. We get 3.4. 6.7 is larger, it's positive, so our answer is positive. Remember all the rules for adding integers. These are not integers, these are rational numbers, but the rules for adding numbers with opposite signs stays the same. So we get 3.4 equals 3.4. That solution checks out. In class, we'll work on worksheet 4.3.